So the next section is about the multi-dimensional list or array. Okay. So what is multi? Okay. So when we deal with multi means it is more than two. What we discussed previously, it was only two-dimensional, but now let's look at the more than two-dimensional. So I have one case study about inventory. Inventory, it is Jigu Guandi. Okay. So a company wants to store the inventory data of 4 products in 3 warehouses for 2 periods of time. Let's suppose the time is January 2024 and February 2024. So the first is the product. Let's say there are 4 products. Okay, so product 1 is, maybe this is the warehouse about sports. Okay. So product 1 is ball, product 2 is the racket, the product 3 is the baseball stick, and product 4 is the gloves. Okay. And this company has 3 warehouses. And then they want to manage the inventory data for each warehouse. It means in the warehouse 1, they have 4 products. In warehouse 2, they also have 4 products. In the warehouse 3, they also have 4 products. Now, they want to know the inventory on January 2024, and they also want to know the inventory on February 2024. So we can make this kind of data. So this data is the data with 2 time periods. And then we have 3 warehouses and we have 4 products. So the inventory data is a list. And then we start with the list. Let me make the closing list. And then the first list in this data is the time period 1 or January 2024. The data in the January 2024, I have the data on the warehouse 1. So on the warehouse 1, we have 4 products. So the product 1, we have 100 data. In product 2, we have 50 items. We have 200 items for the product 3. And for the product 4, we have 75 items. In the warehouse 2, we have 150 items of product 1, 75 items of product 2, 100 items of product 3, and 120 items for product 4. And this is the data for warehouse number 3. This is the data on the time period 2. This is for the February 2024. On the February 2024, this is the data. We have 3 warehouses, so it means we have 3 lists. And then for every list, we have 4 numbers. So 4 numbers means product 1, 2, 3, and 4. So if you look at this structure, okay, so you have a list, and in this list, we have 2 lists. These 2 lists indicates the time. Okay, this indicates the time. And then for each time period, we have the warehouse. and warehouse. For each warehouse, we have a values to indicate the product, 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 product. Then it means there are 3 dimensions. The first dimension is the time dimension. The second dimension is warehouse dimension. And the third dimension is the product. So this is the multi-dimensional this, or yeah, this is more than 2 dimension. Now, with this more than 2 dimension, how can you read the data? Okay. So this is something that you need to look at the data in detail. So I can print the matrix. I can print the matrix like this one. So in the time period 1, in the warehouse 1, we have this inventory of product 1, product 2, product 3, product 4. In the warehouse 2, this is the inventory. In the product 3, this is the inventory. So we have the inventory data. We have the length of the inventory data. The length, this means that the time. So I have 2 time period. In this 2 time period, I would like to print the warehouse. So warehouse, we have 3 warehouses. So we have 3 warehouses, and then for every of these warehouses, there is a value to indicate the product. So it is a list. If you want to split again the list, so what can you do? Let's suppose I want to know the product 1 is ball. Product 2 is what is it? Product 2 is the racket. The product 3 is the baseball stick, and the product 4 is glove. Then how can you split? Means you need to make one more loop. Okay. Now let me just skip this one. So I can make another loop. Oh, okay. The AI already know. So the P, let's say this is the product. Okay. And then I want to create the inventory data. Now I'm going to read the inventory data on the particular time on the particular warehouse. So let me just close this one. Then for every product, I'm going to read the data, and there are 3 kind of indicators. The first is to check time. The second is to check which warehouse, and the last is to check where is the product. So it means, yeah, you can see the product 1 is 100, the product 2 is 50, the product 3 is 200, and the product 4 is 75. Here is the product in the warehouse 2. Maybe if I open this one, then you will see, yeah, this is the product in the warehouse 1. This is the product in the warehouse 2. This is the product in the warehouse 3, and so on. So this is also the product in the each of the warehouse. If we have 3 dimension, can we have 4 dimension? Yes, we can. If we have, this is 1, 2, 3, so 3 dimension. Can we have more than 3? Yes, we can. Can we have 5 dimensions? Yes, we can. Can we have 6 dimensions? Yes. But of course, when you have more than 3 dimensions, it is more complex. And you need to understand the data structure. Now let's see the second problem. It is about the production. A company wants to create a production scheduling. Do you know scheduling? 계획. Okay. 생산 계획. So I want to create the production scheduling for 3 products. Okay. So let's suppose the product is this one. Product 1, product 2, and product 3, for example. Okay. And there are 2 machines. So this is the machine 1 and machine 2. So you can use the machine 1 to produce product 1, product 2, and product 3. You can use machine 2 also to do the production product 1, product 2, and product 3. And for every the production, there are shift. Shift mean whether the workers will do the production in the morning or in the evening. Maybe in Korean, jugan yagan. So if it is in the morning time, then it is maybe from 9 until 5. If it is in the evening, maybe it is from 6 until 4 a.m. in the morning. Then there are 2 shifts, morning and evening. So if you look at this data, or if you look at this structure, it means we have 3 dimensions. The first dimension is the time. The second dimension will be the machine. And the third dimension will be the product. Then we can make also the multi-dimensional list. Okay. Now let's suppose I'm making the production schedule just like this one. Machine 1, I'm going to set up the schedule. So this is the schedule for the product 1. For the shift 1, let's make the schedule 50 products. So in the shift 1, you need to produce 50 products of product 1. For the shift 2, you need to produce 60 products at the shift 1. Sorry, in the shift 2, you need to produce 60 products on the machine 1. This is the product 2. The schedule will be for the shift 1, you need to produce 70. On the shift 2 or in the evening, you need to produce 80. This is the schedule for the product 3 in the shift 1, and this is the schedule or the plan for the production on the shift 2. So we have also the schedule for the machine 2. On the machine 2, yeah, we have this one. This is for the product 1, shift 1, shift 2. Shift 1, shift 2 for product 2, and shift 1 and shift 2 for product 3. Okay. Then in this case, we have 3 dimensions. The first dimension is this one. The second dimension is this one. And the third dimension is this one. Okay. So you can print the production schedule. In this case, there are two machines, 3 products, and 2 shifts. You have the production schedule. It is for 2 machines, 3 products, and 2 shifts. You have the production schedule, machine product shift, and the machine 1 is this one, and machine 2 is this one, machine 3. Sorry, machine 1, product 1, product 2, product 3, and then this is the shift 1, shift 2, shift 1, shift 2, shift 1, and shift 2. What about if you want to print the value for each shift? So, oh, okay. So AI already gives the solution. So I'm going to print the machine, the production or the product, and the shift. So the shift means I have 2 shifts, which is shift 1 and shift 2. So if you look at this one, the production schedule, we have 3 dimensions. M to indicate the machine, P indicate the product, and S to indicate the shift. Okay. If you run this one, you have the machine 1, the product 1. There are 2 values, 50 and 60. And the shift 1 is 50, shift 2 is 60. The product 2, we have 70 and 80. The shift 1 is 70, and the shift 2 is 80, and so on. Okay. Okay, so you learn a lot about this multi-dimensional list. You learn about the 2-dimensional list and multi-dimensional list. Okay. Now let's do some practice. Okay. Let me get back to this program for the nearest 2 points. Okay, I give the matrix multiplication. Did you do this homework? Did you do the matrix multiplication? Oh, okay. Let's look at the code later together. Okay. But before looking at the code, now let's see this. Okay, let's see this example before. Using this code, we can get the nearest distance. The nearest distance is the nearest point. Now, you need to know the distance in the matrix. So I want to print the matrix. I want to know the distance between 0 and 1. I want to know the distance between 0 and 2. I want to know the distance between 0 and 3, and so on. And how? So this is a program to calculate only the shortest distance. Now I want to print for all the distance. Okay, so how to print all the distance? Print all the distance in a matrix. Okay. Okay, the AI give you the wrong answers. Now let's see. I already put this one in the function, main function. Okay, this is the point. Okay, I think because of the variables, these variables inside a function. Do you still remember? Local variable and global variable. Okay, what does it mean by local? It is only for the function. So when the variable is in the function, you cannot use the variable in other function. So you can only use, let's say, this point. It has been generated in the function main. Then there's this variable you can only access in the function of main. You cannot access the data outside the function. Okay. Now let's make let me make just a very simple point. And then I make two dimensional. Let me just make point one. So let's make the 3 point, or you want to make all the things, minus 1 comma 3. Okay. And then I have minus 1 comma minus 1. And then I have 2 comma 0.5. And let's make one more, 2 comma minus 1. Okay, I have this point. Okay, then if I print the point, so it is a two-dimensional points, okay, like this one. Now, I need to find the distance between the 2 points. So the distance is the function. Okay, I have the distance, which is this one. I want to calculate each of the distance between the point. It means I want to calculate the distance between this one and this one. So let's suppose this is the index 0. This is the index 1. This is the index 2. This is the index 3. Okay. And then you want to make a matrix. The distance between index 0 and 1 is this one and this one. The result should be here. And after you have the distance, you will also need to have the distance here, 1 and 0. This one will be the same. The distance from 0 to 1, it will be equal to the distance between 1 and 0. Okay, so let's do one by one. How to calculate the distance? Let me just use this distance function. Okay, I will use this distance function. Now I'm using the variable points 1, points 1, points 1, points 1, points 1, and points 1. Okay, we can get the distance for every 2 points. we will get D. But how to make this into two-dimensional list? Any idea? How to make two-dimensional list? First, you need to make a new list. Let's say you can create any kind of variable name, okay, as long as the variable name is not the Python keywords. Let me just make pp. Okay. So I'm going to make the distance, and the distance from 0, if I have this one, 0, 0, 1, 1, and so on, like this. Then it means this is the index 0, and I will have the value 1, 2, 3, and 4. Okay. Then the list will be like this one, and the next list will be the value of this one, the value of this one, the value of this one, and the value of this one. Then it will be separated by comma, 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 and comma. Then after I have the distance, I will put the distance here. And then after I finish calculating the distance, I will put here. After I finish calculating the distance, I will put here. After I finish calculating the distance, I will put here. And then the list that I have here, I will append into this one. Maybe to make it better, let me just make the name not pp, this distance matrix. Okay. So after I calculate the distance here, after I calculate the distance, then I would like to append into the distance matrix. Now, let me just use the AI. Is it correct? Igo baca yuk. Can I trust AI? You will need two-dimensional list. So the two-dimensional list means you have a list, and inside a list you will have another list. But using the append, it means you will just append the value. So it means this will be only one dimensional. Okay, that's it, the result. Okay, this is the distance. 4, 3.9, 5, 3.3, 3, and 1.5. What is it? This is the distance between I and j, where the j is I plus 1. It means when I equals to 0, j equals to 1. Okay, so it means I will have a kind of matrix like this one: 0, 0, 1, 2, 3, and the value will be 0 and 1, it is 4, and then 3.9, it is here, and then 5, it is here, and then we have 3.3, it is here between 1 and 2, because when I equals to 1, j will start from I plus 1, then j will start from 2, then this will be 3.35, and then next it will be 3, and then we have 2, 2. When I equals to 2, then j will be 2 plus 1, then j will be 3. So this will be the distance of 1.1. Okay. So if you create the matrix, it will be the upper triangle matrix. Do you still remember? Upper triangle. Okay. So if you still remember in the for loop, okay, in the for loop, in the repetition, I teach you how to create the star, star like this one. Okay, we have the upper triangle like this one. So this is the same with this structure. So this is the same, that the value will be only the upper side of the triangle. Then how to print this one? You already have this value. Now we are going to make only in this side. Okay, then let's see. If we have this value, it means we can also see the opposite one. For example, 0 and 1, the distance between 0 and 1, it will be equals to the distance 1 and 0. So the distance between 0 and 1, which is 4, I can put the value 4 here. So this value can be also the same in this one, 4. The distance between 0 and 2 is 3.9. So the distance is also the same with the distance 2 and 0. Then it is 3.9. Okay. So if it is empty, you can fill in with the same value. Now let's do one by one. Okay, let's do one by one. I want to make the upper triangle. So what is the upper triangle? Actually, there are two ways to make it the matrix. If you want to make it complicated, yeah, you can take this one with I plus 1. But if you want to make it simple, okay, so you can remove this one, like this one. Okay. If you remove this one, then you will get all the values from 0 until the number of points. Okay. If you run this, then you will get the value for all points, not only the upper triangle. Now let's suppose I make this one. So for every time, for every j, it means for every row, I will make a new value. Let's say this one, and then let me make an empty list. Whenever I finish with the first, I will append the data into the distance 1. And whenever I finish with the j, So I will make a new row. Then I will append the distance. Can you understand? What does it mean by this? We have 5, 3, 1.5, and 0. Okay. We will do append. We append this one into the distance 1, and then whenever it finishes, we'll append the distance 1 into the distance matrix. At the end, we will print the distance matrix. Then something more. What is the mistake? What is 5? Okay, let me show you. If you have this kind of difficulties, try to do some tracing. The tracing means you can print in every of your result. Let's suppose I want to print the distance. And then I want to know what is the current I, and I want to know what is the current J. And then I want to know what is the distance. Then you will get this one. When the I is 0 and when J is 0, the distance is 0. When the I is 0 and when J is 1, the distance is 4. When the I is 0 and when the J is 2, the distance is this one. When the I is 0, when the J is 3, the distance is 5. Okay, everything is correct. Okay, but why we just save only 5? Why we just save only 5? Every time we append the value, after we append, it will start from empty. Okay, every time we run this one, it will start from empty list. That's why we only save the last value, not all the distance value. So it means I need to remove this one here. So before I start to calculate the distance, let's make it empty. After I go to this volume, I have the distance, and let's append it. The distance will be the same. Okay, the distance will be the same. Now you will have all the distance. Then this will be the distance from 0 to 0, 0 to 1, 0 to 2, 0 to 3. 1 to 0, 1 to 1, 1 to 2, 1 to 3. This one. Distance between 2 and 0, 2 and 1, 2 and 2, and 2 and 3, and so on. Okay. Now, let's print. How to print the matrix? How to print the matrix? We have the function at the upper side. Okay, I show you the print the matrix. How to print the matrix? We will start from the 0 until the length of the matrix, and then we go from the column, also starting from the 0 until the length of the row on the respective matrix. Okay, then let me just get this one. And I'm not using the matrix. Now I'm using the data from the distance matrix. So I'm using the data on the distance metric. I'm using the data on the distance metric. And I'm using the data from the distance matrix. Let me show you, then this is the result. Okay. We have 0, 0.0, 4.0, 3.9, something, 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 5.0. And yeah, this is the distance. Now, let's get back to the maybe week 2 or week 3. This value is too long. So I want to print only 1 digit. What is the comment? You still remember? Round? Okay, that's right. So what is the comment? Round? Okay, if you look at Python, you have this syntax. Round, what is the number? Comma, n digits. N digit means how many digits after the comma that you want to print. So if you understand the concept about this description, yeah, this is a function. Then yeah, you can just apply. This is the number that you want to print. And let's suppose I want to show 1 digit, okay, after the comma. Okay, then you will get this matrix. Okay. Yeah, you can make more beautiful matrix. For example, you can put the header, you can put also the row section. I think last time we have the example like oh, I don't have the example. Okay, anyway, yeah, this is the result from the distance matrix. Now, let's go to the next matrix multiplication. Okay. Yeah, I gave the solution. Okay. So let's try to figure out together. You can try again later at home. But if you go to this Google Colab, you can see also this matrix multiplication. And because I'm using my account, so whenever you run this Google Colab again, you will see the examples. Okay. So every time I updated the examples, you will see the result. Now, let's see the matrix multiplication. So the matrix multiplication, as I mentioned to you, whenever we have the matrix, let's say we have A and B. If you want to do the plus matrix A plus matrix B, it means the size of the matrix should be the same. Let's say we have n multiplied by m matrix. The matrix B also should be n multiplied by m. So the size of the matrix of A should be the same with the size of the matrix of B. How about if we have the multiplication? When you do the multiplication, you have the n multiplied by m, and the column on the matrix A should be the same with the row on the matrix B. It is m. Let's suppose we have another variable. Okay. So if the matrix A, the size is n multiplied by m, and if matrix B is m multiplied by k, then we will get a matrix C, which is n multiplied by k. It means we will get the row of the matrix A, and we will get the column of the matrix B. Okay. Now I have this example. Matrix A is 1, 2, and 3, 4, 5, and 6. So this is a matrix of 2 multiplied by 3. And then 7, 8, 7, 8, 9, 10, 11, 12. So it is a matrix of 3 rows and 2 columns. Then the result will be a matrix of 2 multiplied by 2. 2 multiplied by 2. Now, what is the value of this one? 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 The matrix multiplication, the value of this one will be 1 multiplied by 7. Okay, 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11. Okay, then it means this is 7 plus 18 plus 33. So 25 plus 33. It means this is 58. Okay, then we will put the value 58 here. What is the value of this one? Here will be 4 multiplied by 7 plus 5 multiplied by 9 plus 6 multiplied by 11. Okay, then we will get 28 plus 45 plus 66. Then it means this will be 73 plus 66. So 139. Okay, so here 139. Okay, and so on. So if we want to do this one, then it means this will be 1 multiplied by 8 plus 2 multiplied by 10 plus 3 multiplied by 12. For this one, it means 4 multiplied by 8 plus 5 multiplied by 10 plus 6 multiplied by. So using those idea, we need to make the Python code. So what is the Python code? Yeah, at the first time, I'm just making the requirement. If you want to make the matrix multiplication, the column A must equal to the row of B. Okay, as I mentioned to you, the A m multiplied by n should be have the n multiplied by k. So this one should be the same with this one in order to do the matrix multiplication. If it is not the same, then you cannot do the matrix multiplication. So we are going to check the length. What is the row A length? The column A length, the row B length, and the column B length. And then check. If the column A not equal to the row B, then give the error. Okay. If not, then this is just making the initial matrix with 0. If you do not want to do this one, it's also okay. You can just use something like result matrix. Yeah, you can you can make something like the empty list like this one. Okay, but if you want to make this empty list, you need to use pen. Okay. So every time you have a new value, you need to append. You need to append. You need to append. If you set up, the code like this one, so you will have the initial matrix at the first time, and then you can just update it. So here, I think you already learned about the list comprehension. Do you still remember? Okay, we put everything in the list. So it means I'm going to put 0 for all the columns and the rows, because I know that the matrix multiplication result will be equals to the, for example, A n multiplied by n, it will be B n multiplied by k. So the result will be C m multiplied by k. C m multiplied by k. What is m? M is the length of the row A. M is the length of the row A. And what is K? K is the length of the column B. K is the length of the column B. Then I'm going to make a matrix where the row will be the column. Oh, sorry. The row will be the row A. Okay. The row A is this one. And the column will be the column B. Okay, please take a look again for this list comprehension. Okay, this is the list comprehensive that you already learned before. After we have this one, we have the matrix multiplication. For I in the row A, and let's check the J. For J in the column B, now we have another variable, this is K. So let's see like this one. I have the row A. So let's suppose this matrix. Okay, I have the row A which is 2 rows, 1, 2. And then I have J, sorry, J is the column B. J is the column B, 1, 2, 3. Okay. Now for every K, it means I'm going to iterate. I'm going to iterate for 1 and 7, 2 and 9, 3 and 11. So it means this one. On the matrix A, it will be matrix 0 and 0 multiplied by matrix 0 and 0 plus, what about this one? It is the matrix 0, comma 1 multiplied by matrix on the row 1 and column 0. And then plus the matrix on the column 2 multiplied by the matrix on the row 2, column 0. Okay, so it means 0, 0, 1, 1, and 2, and 2. Then we use this one. When K is the same with the column A, what is the column A? Okay, this is the column A, 0, 1, 2. So it means from 0 until 2. Then when K equals to 0, this one. Plus when K equals to 1. Plus when K equals to 2. So we have this one, matrix I, K multiply matrix P, K, J. So when I equals to 0, when K equals to 0, this one is K equals to 0. This is K equals to 1, and this is K equals to 2. Okay. Then we will do the loop until all the row and the column, and we get the result. So the result of the matrix will be this one. Multiply the multiplication of A and B will be 2 multiplied by 2. Okay. I have another alternative, but I think you don't need to do this one. This is more simple, but you need to use a library, which is NumPy. But I will just skip this one. If you want to look at the reference, you can use this one as well. But what I want to show to you is this matrix multiplication. Okay, please take a look on this one for your reference. Okay, I think it's the time. So I will finish the class and